Before the refrigerator, food had a clock. Milk could spoil overnight. Meat could become dangerous within days. Fresh vegetables belonged to the seasons in which they grew. And in the hottest parts of the world, heat was not simply uncomfortable. It was a force that decided what you could eat, what you could preserve, and sometimes whether you survived. Today we open a refrigerator without thinking about it. A light comes on. Cold air surrounds a carton of milk. A compressor hums somewhere behind the wall, and we close the door. The food remains cold. It feels ordinary because we have become completely accustomed to it. But that ordinary box represents one of the most important victories in human history, the ability to manufacture cold. And the strange part is that humans did not begin by inventing the refrigerator. They began by stealing cold from nature. Long before electricity, compressors, or refrigerators, people already understood one simple fact. Ice could preserve things. The problem was keeping it. For most of human history, cold was not something you could produce whenever you wanted. It was something you had to find. In ancient civilizations, people harvested snow and ice from mountains, stored it in underground pits, and insulated it with materials such as straw, sawdust, and earth. Thousands of years ago, people in places as different as Persia, China, Greece, and Rome developed ways to store ice or use naturally cold environments for preservation. In ancient Persia, engineers built enormous structures called yakhchals. These were massive dome-shaped buildings designed to store ice through the hot months. Ice collected during winter could be placed inside deep underground chambers, protected from the heat outside. The walls were thick, the interiors were shaded, and clever ventilation helped maintain the cold. Imagine living in a desert where summer temperatures could become brutally high, yet somewhere nearby, beneath a giant earthen structure, blocks of ice were waiting. That was not refrigeration. But it was the beginning of the idea. If humans could not make cold, perhaps they could capture it. The Romans took a different approach. Snow and ice were transported from colder regions and used to chill food and drinks for wealthy households. The practice was expensive. It required labor, transportation, storage, and access to cold climates. Cold was therefore a luxury. The wealthy could drink chilled beverages in warm weather. Everyone else simply endured the heat. For centuries, that was essentially the state of the technology. Human beings could preserve food with salt. They could dry it. They could smoke it. They could ferment it. They could pickle it. But when it came to cold, they were dependent on nature. Then, gradually, something changed. People began discovering that they did not necessarily need ice itself. They needed the effect that ice produced. And one of the simplest ways to produce that effect was evaporation. If you have ever stepped out of a shower and suddenly felt cold, you have already experienced the principle. Water evaporates from your skin. As it changes from liquid to vapor, it takes heat with it. Ancient people discovered versions of this principle long before anyone understood the physics behind it. In hot climates, water could be placed in porous clay containers. As water slowly evaporated through the walls, it carried heat away from the container. The result was cooling. It was primitive, but it revealed something profound. Cold did not always have to come from ice. It could be produced by manipulating heat. That distinction would eventually change everything. But before humans learned how to manufacture cold, they had to create another invention, the ice house. Across Europe and North America, wealthy households, estates, breweries, restaurants, and businesses began constructing underground or heavily insulated structures for storing natural ice. During winter, workers cut enormous blocks of ice from frozen lakes and rivers. They loaded them onto sledges. They transported them to storage houses, and they packed them tightly inside insulation. The goal was simple: make winter last into summer. This created an unusual industry. Cold itself became a commodity. In the 19th century, one man would transform that idea into a global business. His name was Frederic Tudor. Tudor became known as the Ice King, and his idea sounded almost ridiculous. He wanted to harvest ice from frozen New England ponds and ship it to hot parts of the world. At first, people thought he was crazy. Why would anyone pay to transport something that melted? But Tudor developed methods for cutting, storing, insulating, and shipping ice. His ice could travel thousands of miles. Ships carried enormous blocks across the ocean. Ice was sent to the Caribbean. It reached India. It entered markets in cities where natural ice was practically unimaginable. And suddenly, cold could travel. But there was still a problem. Natural ice was unpredictable. It depended on winter. It melted. It required enormous amounts of labor, and transporting it across the world was expensive. Humanity had learned how to preserve cold. The next challenge was far more ambitious. Could we make cold ourselves? The answer began emerging from an unexpected place: the laboratory. Scientists had already begun studying the relationship between pressure, evaporation, gases, and temperature. One of the most important discoveries was that when certain liquids evaporate, they absorb heat from their surroundings. This was the physical principle behind artificial refrigeration. In the early 19th century, inventors began experimenting with machines that could create cooling mechanically. One important early figure was William Cullen, a Scottish physician and chemist. In the 1750s, Cullen demonstrated an artificial refrigeration experiment using a vacuum to encourage evaporation and produce a small amount of ice. It was not a practical refrigerator. It could not cool an entire kitchen. It could not preserve a household's food, but it proved something extraordinary. Humans could create cold artificially. The idea was now on the table. Over the following decades, other inventors pushed the concept further. In the early 19th century, Michael Faraday experimented with liquefying gases and discovered important relationships between pressure, evaporation, and cooling. Then came inventors who tried turning these laboratory principles into machines. In the 1830s, Jacob Perkins, an American inventor working in Britain, developed a practical vapor compression refrigeration system. His design used a closed cycle involving a refrigerant, compression, condensation, and evaporation. It was an early ancestor of the technology inside your refrigerator. But there was a problem that would appear again and again throughout the history of refrigeration. Making the machine work was one thing. Making it useful, reliable, affordable, and safe was something else entirely. Early refrigerants included substances such as ether and ammonia. Some were flammable, some were toxic. The machines were expensive, they were large, and they required skilled operators. So the first practical applications of artificial refrigeration were not inside homes. They were in industries where refrigeration could make enormous amounts of money. One of the biggest was food, especially meat. In the 19th century, the growth of cities created a huge logistical problem. Millions of people were moving away from farms. Cities needed enormous quantities of food delivered from increasingly distant places, but meat spoiled fast. The solution was not simply to produce more food. It was to control the temperature of the food while it traveled. Refrigerated ships transformed the global food trade. Meat could be slaughtered in one part of the world and transported to another. Fruit could travel farther. Dairy products could reach distant markets, and the geography of food began to change. Refrigeration did more than keep food cold. It changed where food could be produced. It changed how cities were supplied. It changed international trade. It helped create the modern global food system, but there was still no refrigerator sitting in the average home. For ordinary families, the traditional icebox remained the solution, And the icebox was exactly what its name suggested. It was a cabinet with a compartment for a block of ice. The ice cooled the surrounding air. The cold air settled downward. Warm air moved upward. Food was placed inside. And when the ice melted, someone had to replace it. The system was simple. But it came with a strange new household routine. You needed an ice delivery. In many cities, ice men traveled through neighborhoods delivering blocks of ice directly to homes. Families would place signs outside indicating that they needed more. The ice would arrive. The delivery man would carry the heavy block inside. He would place it into the icebox. And the cycle would begin again. The refrigerator, in other words, did not originally mean a machine. It meant a way of organizing cold. Then electricity changed the equation. As electric motors became more practical, refrigeration machinery could become smaller and more suitable for commercial and eventually household use. By the early 20th century, several companies and inventors were developing mechanical refrigeration systems for homes. But early household refrigerators were far from the clean white boxes we recognize today. Some were enormous. Some were expensive. Some had separate mechanical units mounted outside the cabinet. And some used refrigerants that could be extremely dangerous if they leaked. This created another problem. The refrigerator had finally learned how to manufacture cold, but it had not yet learned how to do it safely. Then, in the early 20th century, chemists developed a new class of refrigerants called CFCs, or chlorofluorocarbons. These compounds were stable, effective, and far less toxic than many earlier refrigerants. They helped make mechanical refrigeration dramatically more practical. Refrigerators became safer. They became more reliable, and gradually, they became more accessible. One of the most important milestones came in 1913, when Fred W. Wolf introduced an early domestic electric refrigerator design. Other companies soon entered the market. In the 1920s and 1930s, refrigerator manufacturers refined the technology, improved reliability, and began turning refrigeration into a mass consumer product. The refrigerator was no longer merely an industrial machine. It was becoming a household appliance, and that changed everyday life in ways that were easy to overlook. Before refrigeration, families had to plan food around spoilage. After refrigeration, leftovers could wait. Milk could last longer. Meat could be stored safely for longer periods. Fresh food could remain available outside its natural season. Shopping habits changed. Kitchens changed. Supermarkets changed. And eventually, entire food cultures changed. But perhaps the most important change was psychological. Cold became invisible. Nobody had to think about where it came from. You simply opened the door. That convenience depended on an astonishingly elegant physical process. Inside a conventional refrigerator, a refrigerant circulates through a closed system. The compressor squeezes the refrigerant, raising its pressure and temperature. The hot refrigerant then moves through coils where it releases heat to the surrounding room. It condenses into a liquid. That liquid passes through an expansion device where its pressure drops. Now the refrigerant becomes cold. It enters the evaporator coils inside the refrigerator. There it absorbs heat from the food compartment. The refrigerant evaporates, and the cycle begins again. This is the part that feels almost backwards. Your refrigerator does not create cold in the way a fire creates heat. It moves heat. It takes heat from inside the refrigerator and dumps that heat into your kitchen. That is why the back or underside of a refrigerator can feel warm. The machine is exporting heat. The cold inside is essentially the result of heat being removed. And that simple idea conquered an environment humans had spent thousands of years trying to escape. But refrigeration came with a hidden cost. The same chemicals that helped make refrigerators safer and more practical created a global environmental problem. CFC refrigerants were eventually discovered to damage the Earth's ozone layer. When released into the atmosphere, they could contribute to the destruction of ozone high above the planet. The consequences were enormous. The refrigerator had become a symbol of technological progress, but now the technology itself was changing the planet. In 1987, nations around the world agreed to the Montreal Protocol, an international agreement designed to phase out substances that damage the ozone layer. Refrigeration technology changed again. New refrigerants were introduced, older chemicals were gradually eliminated, and engineers continued searching for ways to make cooling more efficient and less environmentally damaging. Today, the refrigerator is undergoing another transformation. Modern refrigerators can contain digital temperature controls, sensors, variable speed compressors, automatic defrost systems, water dispensers, ice makers, and internet connectivity. Some can detect when food is running low. Some can display information on their doors. Some can connect to smartphones. But beneath all of that technology, the basic mission has barely changed. Remove heat, keep food cold, preserve what would otherwise disappear. And that is what makes the history of the refrigerator so strange. It is not really the story of a box. It is the story of humanity's changing relationship with time. Before refrigeration, food had a deadline. After refrigeration, that deadline moved. A harvest could survive beyond the season. Milk could travel farther. Meat could cross oceans. Cities could grow without being surrounded by farms. Entire industries could emerge because temperature was no longer entirely controlled by nature. And something even bigger happened. We stopped thinking of cold as a place. For thousands of years, cold meant mountains, winter, snow, ice, underground chambers, dark caves. A refrigerator changed the meaning of cold. Cold became something you could manufacture, something you could carry, something you could switch on. Something you could have in the middle of summer, in the middle of a desert, inside a kitchen on the hottest day of the year. That may sound ordinary now, but it is not. The next time you open your refrigerator, listen for the quiet hum. Behind that ordinary door is a chain of inventions stretching back thousands of years. Ancient people storing ice beneath the earth. Merchants transporting frozen blocks across continents. Scientists experimenting with evaporation. Inventors building machines that could manufacture cold. Engineers developing compressors and refrigerants. Factories turning refrigeration into a household appliance. Chemists discovering that even a successful technology could have unintended consequences. And modern engineers trying to make the entire system cleaner and more efficient. The refrigerator did not conquer heat by destroying it. It conquered heat by learning how to move it. And perhaps that is the deeper lesson in the history of everyday objects. The inventions that change civilization do not always arrive looking revolutionary. Sometimes they look like a wooden box filled with ice. Sometimes they look like a machine humming quietly in the corner of a kitchen. And sometimes the greatest transformation is simply this. Something that once belonged to nature becomes something humanity can control. For most of our history, we lived according to the temperature around us. The refrigerator helped us reverse that relationship. We learned to make winter inside a box. And once we did, the modern world became possible. If you enjoyed this journey through the history of the refrigerator, there's a lot more hiding inside the everyday objects around you. From the food you eat to the technology you use every day, Exhibit A uncovers the forgotten stories, surprising inventions, and historical turning points that changed the way we live. Subscribe to Exhibit A and join us for the next story hiding in plain sight.